questions. You can tweet at Science Gallery Dublin, fairly self-explanatory, at Joe Boating, at Megafloods, at DJ McKeown, at Nevi Poos. Also, hashtag #EndIsNigh is the event, and also the wider event is hashtag Science Week, and the wider movement is hashtag Science Rising. Great. So we'll take some questions at the end, but feel free to log your questions during the event, and we'll try and get to them. So to kick things off, I'm just going to invite my panel here to introduce themselves and tell us a little bit about their background. Mary.
Hi, I'm Mary Burke. I'm Professor in Geography here at Trinity College Dublin. I am a physical geographer, a geomorphologist that spent the last 10 years before I came to Trinity working for NASA on Mars data that was returning. And during my time, there was a lot of people that I worked with that were studying impact craters and the effects of impacts. So today I'll be speaking about the hazards that might be resultant from impacts on our planet.
So I'm Dave McKeown. I'm assistant professor over in mechanical engineering. I've been in Trinity 1 week. Before that, I was in UCD, and there I worked with European Space Agency doing control for their next generation of rockets. It's part of their Future Launchers Preparatory Program. So I move around things in space, especially things which are bendy and flexible and sloshing. Also run Dublin Maker, which is a making event, and Science Hack Day, which is a hackathon for science.
It's me now, is it?
Yes.
Hello, my name is Neve. I'm not a professor of anything. I'm a renegade who ran away from academia about 13 years ago and went and flew to the circus of performing and then came back to science when I regained my passion for all things science and particularly space. So now I communicate science and space. I make events for families and for the general public. Sometimes it's theatre, sometimes it's lectures, sometimes it's on the radio. But the absolute core of everything I do is to ignite people's curiosity and try and bring people back to fall in love with space the way I had to about 10 or 13 years ago. I have a number of events happening this week. I have been involved in trying to genuinely get to space since 2014. Yes, I know. It's really crazy. And I'm off to the Utah desert in January, actually, on a simulated mission to Mars for 2 weeks. And lots of other things. But sure, we'll get talking, will we?
We'll get there, yeah. That should come up in conversation.
I'm sure, once or twice.
So in order to start thinking about the threats that the Earth faced, I guess, like a lot of people, the thing I always think of is Armageddon, which is really sad because in terms of science, it's a terrible movie, but it's wonderful in other ways.
Bruce Willis.
Bruce Willis is wonderful,
yeah.
Yes. Mary, can I ask you what the likelihood is of us being destroyed by an asteroid?
Depends where you live. Really it does. And it depends on how big an asteroid is that's coming in towards us. So if it's something like the asteroid that wiped out the dinosaurs on our planet, it was reputed to wipe out the dinosaurs, as well as 70% of the other terrestrial and marine species at that time, that's going to wipe out the human species. And that's a very low frequency event. Maybe once every million years or so. And that event happened 65 million years ago. So between millions and hundreds of millions of years ago is the recurrent interval. And if that were to happen, the effects would be instantaneous. You wouldn't really know what had happened if it came to Earth by surprise. There would be basically the first impact, which is this large asteroid that comes down and slams into our planet. It may slam into a continent, it may slam into an ocean. The probabilities are higher for an ocean because, of course, 70% of our planet is covered by water. It would create a massive cavity in our crust, and it could be so large and so deep that it might stimulate volcanic eruptions. But immediately it would send out shock waves, earthquakes, through vast thousands of kilometers, which would be immediately followed by a huge fireball of superheated gas that would set flame to forests and anything that was combustible under those temperatures. People, all animal life, human species would be destroyed. And so you have your immediate impact. If it's in an ocean, it would create a massive tsunami. There are models that you can have 1,000 feet high wall of water coming in from the ocean, and when it hits the continent margin, it would wipe out everything on that continent margin. So now I want you to start thinking about, we have the impact, and then we have all these links to other, it stimulates other dynamic processes to happen. So you've got the water moving in a wall. You've got the impact that has ejected out massive amounts of hot molten rock and dust into the atmosphere. Some of it goes up into the atmosphere and the larger parts would fall down around our globe, starting wildfires in other parts of the globe that the fireball, immediate one, didn't reach. You would have dust that is in our atmosphere that would darken our planet, cool our temperatures, block out the sun. So processes like photosynthesis, if your plants weren't destroyed by the fire, they would, within a seasonal cycle, be destroyed by a lack of solar energy coming in to start that photosynthesis process.
None of that's good.
No.
I found that when we talk about humans being killed by the fireballs and the tsunami, that's bad, but it really hits me when we say the animals are going to die as well. I feel like they don't deserve it. But if it's an event of that scale, which is better? If it's an asteroid so big that it's definitely going to ruin everything, would you want to know in advance, or is it better to know nothing?
Who here would like to know in advance if the planet was going to be wiped out?
But what if you can't do anything? Would you still want to know?
Well, maybe we can.
Maybe we can. Moving on to other panellists, do we have a solution? Neve, save us.
Yeah.
Well, there's a lot of planets out there, we're getting to know more by the day, like they've got, I think it's 40 billion they've discovered now at this stage. So there are lots of, there's an amazing telescope, the Kepler telescope, which is just looking at a certain sector of our space area, and it's already identified a number of planets that are out there, because about 30 years ago we had this revelation that we weren't the only system that had planets orbiting a star. And since then, we've had to really readjust our own perception of ourselves in the middle of this vast universe. So there's lots of astronomers out there looking for planets that are in a Goldilocks zone, which is, not too cold, not too warm, just right. And most stars have a range of planets orbiting about themselves, and some of them are in this sweet spot. And some of them also have, the possibility of having an atmosphere and possibly water. And so they're chronologically working through a series of them to see what our options are should this happen. It might take a while, we can't do it next week or by next Christmas, but certainly, scientists are now focusing on that and having plans ready should that ever happen. So what they've identified most recently, which is a great revelation, is the nearest planet to us would be in a star system of Alpha Centauri, which is our nearest neighbour, which is 4.2 light years away, just from here to super value, effectively, in terms of space-time. 4.2 light years, only a hop, skip and a jump, where 1 light year is 10 trillion kilometres. But sure, when we make the spacecrafts to do that, that'll be no problem to us whatsoever. But there are people working on this, thinking about 200 or 300 years ahead. I've been very privileged to speak to a lot of space scientists over the last couple of years in my own pursuit, and these people are thinking that long term, and they're trying to come up with rocketry and space systems to get us to these planets as alternatives. And that's a lot of the reasons why we're so interested in getting to Mars, because by getting to Mars, we'll also be able to figure out the engineering and rocketry and everything. So all is not lost.
So there are options maybe further down the line.
The elite will only be able to go, but sure, that's for a whole other day.
But part of the good news is that if it is a really big object, we have the capabilities, the technological capabilities to detect it so far out that it will be maybe 1,000 years or several hundred years before it will hit us. So we have the time to develop the technologies to rescue some of
the elite.
Yes.
What might we do if...
So there's other solutions apart from leaving our planet and trying to go for another planet. Good, yeah, right. So there's a few things, and the big thing is that detecting it early. So the more time we have, then that gives us most time. So if something's coming towards us, we only really, and it's from miles and miles away, or millions and millions of miles away, you only have to deflect its angle a tiny little bit when it's so far away that it'll miss the Earth when it gets here. The closer it is, then you have to divert the angle more. Right. So the sooner we know, the better. So the ideas that people come up, one is basically like a snooker table. Basically, this thing's coming like a ball to hit us. We throw something up to deflect that ball with another ball. So we need to throw something up with a bit of mass or moving very, very fast, which will hit into this asteroid and deflect it a little bit. So that's one option. Problem with that, if you break it up, you might end up having an asteroid that's coming, which might be 100 kilometers across, and that will destroy the Earth. And you break it up into 100 bits, and now you have 100 asteroids 1 kilometre across, which will also destroy the Earth. So you've made the problem a bit more
And if
difficult.
you use a nuclear bomb to do it, they're all radioactive.
Yeah.
Yeah, so that's
They're
not
not only
good.
going to smash us, they're going to actually kill us
You
slowly
need to
with
just
radiation.
nudge it, don't you?
You need to nudge it a little bit.
Yeah.
There's one option is to have some explosive, a nuclear bomb. And the idea is not to blow the thing to smithereens, but to kind of explode the bomb while it's kind of off the surface of the asteroid, which will then, it's just kind of that shock wave, that pressure wave will push the asteroid away.
Well, that's where Armageddon got it wrong, right?
That's
Yeah.
where they got it wrong.
Yeah,
Bruce
one of the ways.
So one is either we land on it with an engine and try to fire the engine and push it that way. Another kind of cool way is a thing called a gravity tractor. Yeah, which is the best kind of tractor. And it's basically that you fly alongside the asteroid or comet, and then there'll be a gravitational pull between the two of them. So the asteroid will be kind of, just because of gravity, drawn towards the spacecraft very, very slowly over a long period of time. So it just goes beside of it, and they kind of get closer, and the spacecraft will keep a kind of a distance. It'll try to be close to it, but doesn't want to be orbiting it. It wants to be pulling it one way. So again, over a very long period of time, you can do it. But you only need to change the velocity of an asteroid by a couple of millimeters per second, kind of, to make sure that if you have a year, you need to change it to like 3.5 millimeters per second to make sure it misses Earth.
So a problem with that is almost geopolitical. So China decides this is coming in and we're going to put up our gravitational tractor up there. And what happens is you're very slowly changing the trajectory. And what you're doing is you're moving the zone of hazard from China, depending on which way you're going, across our globe. And suddenly it's sitting over America.
Uh-oh.
And how is America going to feel about now China has moved this hazard, that if they mess it up or something goes wrong, it's going to impact the United States of
Shouldn't be a
America?
Be fine.
Trump will not be in power anymore.
There's an interesting argument about maybe painting an asteroid and having some sort of differential between the two colours. So is that something that's actually viable? Like covering half the side of an asteroid with white paint and then hoping that the radiation pressure would slowly nudge it along?
I guess if it's far enough away, but if it's far enough away, then you're further away from the sun, so you don't probably get as much solar pressure.
Who's going to paint it as well, Joe? It's
Well,
big.
yeah, that's the thing. So in Armageddon, they need to send someone to stop an asteroid.
Yeah.
So rather than sending an astronaut, they look for people who are really good at drilling holes and stuff.
Yeah.
Because that makes sense.
Yeah.
So I think if you're going to
Totally
paint an
sense.
asteroid, what they're going to look for is like
Painter decorators.
yeah, or
Yeah.
even better, like people are just spray painting on the street.
Yeah, like
Yeah.
urban artists.
Urban artists,
Love it.
yeah. It'll be like a delinquent to riches
Yeah,
Hollywood
but it'll
story.
also be a piece of art that could potentially destroy us. It's so disruptive. I love it. Let's do
Yeah.
it.
How do we feel about that as a threat? Is anyone worried about asteroids? Great, no one's worried about
No one's
asteroids.
worried about asteroids.
Yeah, happy room. If
How frequent are they? How likely?
Depends on the size. So we recently had one
Yeah, it was quite recent, Mary, wasn't it?
2013 over Siberia. It was an incoming asteroid that didn't actually hit the surface. It exploded 23 kilometres above us, and it sent out a hazard which is known as an air blast. So the first thing that happened was people saw this bright, really bright flash of light. And they were all in school and in work, and they all went over to the windows to look out the windows. And the next thing that happened 2 minutes later was the sound wave came smashing through their windows and smashed the glass in on their faces.
Oh, gosh.
And so nobody was killed, fortunately, but the major impact, literally, was on their faces. They all had to get stitches on their faces, the children and the people who were just looking out their windows. If that had exploded further down, closer than 23 kilometres, over that area, millions of people would have been killed. We were lucky. We were so lucky that incoming asteroid was so fractured and under the pressure coming through our atmosphere just broke up so high up. If it penetrated a little bit deeper, we would have been in big doo-doos. And this is the first time that we as a kind of a civilization, an urban civilization, have got a real handle on, crikey, this could happen to an urban area. And that's what I meant when I said it depends where you are. If you're in an urban area and one of these comes in on a trajectory towards you, yes, you're likely to be killed. If you're living out in a remote area in a desert, it's probably not so likely that you will be.
And Mary, do they not predict that was going to happen? Like, isn't
No,
their
they
planet-
missed it completely. They had no
How did
idea.
they
They were
miss
watching
it?
another asteroid
Oh my gosh.
that was a risk. And they completely missed this one. It took everybody by surprise.
Because I saw some great YouTube videos of
I know,
that.
everybody had these web dash
Everybody
cams.
had these
Yeah.
web dash cams.
why do people have so many dash cams?
thing.
Speed checks.
Yeah.
See, there's always a benefit.
I think there's a lot in Russia because apparently insurance is really hard.
Yeah.
It's really expensive, so it's cheaper to buy a
Just record.
dash cam and then say you're not at fault and get the insurance.
And you get cool videos of
That's right. Yeah.
But the other one, a pal of mine a few weeks ago was online. He was kind of going, I just saw this blue, just a blue streak across the sky. He didn't know what it was, and they later reported that it was some sort of meteorite or something. So this happens all the time, doesn't it?
Yeah, we found 6 rocks from space in Ireland.
Wow.
Mm-hmm.
We have recovered 6 rocks from space. We do see them in Ireland all the time if we have a cloudless sky. But to have these recovered from our own little island is quite, like, they've hit people on the head, they've come through the roof, past their toilet and down into the attic. These things have been recorded in the last decades all the time. They make the headlines in the news. They are a hazard. They punch through cars. There's some very famous examples of this. Yeah, so it's... But they're not going to cause like the extinction of a species or what. They're going to basically.
But if they hit you on the head,
there's a woman who got hit on the hip and has been. Yeah, there's lots of injuries.
You always have one friend who, like, bad things always happen to them.
Yeah.
So they're definitely going to get hit by a meteorite. Life advice there: if you see the bright light, don't go to the windows. Always put your face down.
And just to correct this idea of shooting stars, they're not stars. They are stuff that's coming through our atmosphere, and it's heating up because of the density of our atmosphere, and it's basically going on fire, and most of it just disappears and crumbles into dust, and we have a constant rain of space dust on us. But if you see this flash, don't call it a shooting star anymore. It's an incoming object from space, which
romantic,
may be
though.
one that we put up there. Yeah.
Oh, look, there's an incoming object coming on my date.
we do try to track all these objects. These things that are going to come near Earth, we call them near Earth objects, NEOs, and there's certain programs that try to track all these things, so we know that they're coming. And a lot of it's ground-based telescopes, so you're just looking up and tracking. And there's some things in space that look around, and then there's databases that keep track of all these things. I think NORAD in America, they keep track of them.
Santi, they keep track of
Yeah, Santi. That's their real
Yeah.
job, is on Christmas Eve
Yeah.
to tell you where Santi is going around the Earth. But also they track asteroids. Yeah. So we have some idea, but they're trying to get smaller and smaller. I think the goal was to have, I think maybe in the early 2000s, 90% of everyone that was bigger than a kilometre wide, and now they're going to try to get everyone that. So that would
But they're
destroy
not
Earth.
putting the money in it.
Yeah, because
Congress said
that
let's
was
map
it.
them all.
Yeah, they were going
but
to do that.
they've
That
run
was
out of
planetary
funds.
defence was the prime thing in Obama's reign, wasn't it? But obviously, they haven't. That's not going to happen now.
Yeah. Well, they're still working at it, and you've got non-for-profit organisations that are on the
They're
game as
still
well.
doing it.
Yeah.
So there's the small impacts that would ruin a city or ruin your day if it's just hit
And
your
your
head.
coffee table.
Or your coffee table. And then there's the big ones that mass extinction wipes out everything. What about the ones, and this is like, we've had some nice science, this is probably a little bit speculative. What about the ones where it causes extensive damage, but humans don't quite get killed off altogether? Do you think as a species we're equipped to survive on a planet after a global catastrophe?
Well, I don't know. I mean, it's hard to say. I mean, you kind of just have to go through it, don't you? I mean, there's been so many movies and stuff. Road is... Have you seen Road?
Oh,
have you seen
bleak.
Road?
Yeah, Cormac
Oh,
McCarthy.
good God. It's just like, it's so scary. I don't know if I'd actually want to be alive after some sort of catastrophe, but I think it's the human condition to survive, isn't it? You know, like we have, at different periods of history, we have pushed ourselves to the limits. I mean, I always think space, the analogy for me always about, space exploration is always when I think about people who went to America and kind of started again, and probably landed in America with beautiful forests and then hacked them down and kind of built homes. And in order to get there, they would have had to travel across seas like for 6 or 9 weeks at a time. And now look at America. You know what I mean? Like, I think the human condition is an incredible thing. So if people survive, I reckon we'll make it work. It'll be pretty bleak, but I think if people survive, I mean, that's what the Omega Man was about. That's what I Am Legend, although a poor equivalent to the Omega Man, was about. There's a whole genre of kind of science fiction movies about that. I really worry about that. I kind of would prefer not to survive. I don't know. I'd be like, oh God, just tell me when I can come out. And you've made me a city.
We have survived.
Yeah, we have.
There's been a really cold kind of glacial period recorded in our Earth history about 11,800 years ago, and somebody speculates, not somebody, scientists, a cohort of scientists speculate that it was one of these big air blasts over North America. And we've seen that it's proposed to have got rid of all of the megafauna, the mammoths and all those kind of large animals that were occupying those territories. And why they think there was a big air blast was that Northern Europe was covered in massive glaciers, big ice caps. And right about that time, there was a sudden peak in temperature. Everything got hot. And they know this because suddenly all these icebergs started calving off glaciers, and all this meltwater melted from the glaciers and went into the ocean, changed the ocean and changed therefore the climate because the waters got cooler and all that. And so the human species survived that. So that's, you can think regional in terms of a continent. It's been detected across Europe as well, that we had loss of species, we had extinction of species, we had a minimal kind of expression of humans on the continent in terms of their expansion and settlement. But we had developments of technologies. We had agriculture suddenly start developing over in Syria. And so just like the extinction of the dinosaurs led to us, 70% of the species on our planet went extinct as a result of that big impact. Mammals started to dominate, and we evolved from that. So the same thing happened 11,000 odd years ago. So perhaps something similar. We've shown that we can survive a minimal impact. If it's global, no, we're not going to survive.
Okay, but there's precedent there for...
Yeah.
Okay. So, I mean, as well as asteroids, that's the one we always think of. But there are other local threats, more close threats, such as clowns that have left circuses. No. One thing we often forget about is the sun. It's right there. It gives us light. But should we be worried, David?
Should we be worried? The sun's the main thing in our solar system. It's maybe 99% of everything in our solar system. Big ball of plasma. And it's probably the hard limit on the end is nigh, is probably the sun. So in about, 5 billion years, 5.5 billion years, the sun will run out of fuel. It'll expand into a red giant. It will envelop. It'll grow, get really, really big, take in the Earth, and we'll all die, definitely. So everything we talk about is underneath that limit of 5 billion years. In the meantime, the sun tends to spit stuff at us just to annoy us in the meantime. So it does in two ways. One is solar flares. So the sun is obviously very, very hot. Very, very hot. And so the atoms inside the sun, they get ionized. So the electrons leave the atoms and get this kind of flow of electrons going around the sun, which turns the sun into a magnet. So you have this kind of magnetic, big magnet, and also lots of gravity because it's just a huge thing. So it's this kind of tumultuous fight between the magnetic field and gravity in the sun. And sometimes these magnetic fields get twisted, and we end up with kind of uneven areas in the sun. You get these kind of sunspots which are cooler because the hot gases can't come up because of the magnetic field. And then occasionally they all kind of untwist and you get a kind of a solar flare, which is kind of a lot of basically radiation. You get light coming off it, but you also get X-rays and gamma rays coming off it, which then start kind of heading towards Earth. The lucky thing is that the Earth's atmosphere tends to protect us against this, so it can just get absorbed there. It does affect our kind of satellites and stuff that are up orbiting the Earth that are outside the protection of the atmosphere.
And astronauts, I guess?
Astronauts, yeah. So guys up and doing spacewalks in the International Space Station, they got to worry about solar flares.
Yeah. Mars rovers, they shut them down when there's a big flare going across our solar system.
Poor little Mars rover.
God love them. They're hard jobs.
So the second way that the sun spits at us is coronal mass ejections, which are kind of more scary. So that's basically when it's kind of the same. They happen a lot of time when solar flares happen, but not always when solar flares happen, and the other way around. But it's basically now the sun spits out billions of tons of particles, and if that comes towards us, then we're in trouble at the Earth. So not only is it just like light or X-rays, it's this kind of shock wave of kind of a magnetic field. So it comes and it takes a few days to get from the sun to us, and then when it gets here, it interacts with our magnetic field. So the Earth has a magnetic field, magnetosphere around us. And just like you might imagine, if you've got two magnets and start pulling them together, you get this kind of interaction, and our field starts doing weird things. Maybe what you probably know it best is for the Northern Lights or Aurora Borealis, is that you get these particles coming into our atmosphere, ionizing again our oxygen and nitrogen, so ripping electrons from it, and then when the electrons go back into the atoms, you release this color, and you see all these beautiful colors. But in a more kind of extreme, what's going to happen to the Earth problem, again, our satellites get hit by all these particles, which can create, ionize them, create shorts, and blow them up. It will, if you have a magnetic field, it can induce electric currents, okay? So if you change the magnetic field, so power lines around the Earth, if our magnetosphere starts changing, it'll induce currents, which the system's not ready for in it, so that the load of electricity on Earth gets much bigger, which will blow up our kind of our electrical grid, which is cool, right? Not so cool when you have to deal with it, but do that, it'll blow out could blow out our GPS satellites, our communication satellites,
Mobile phones,
radio waves will be the medium that they're going through is going to be all messed up. It's going to change the magnetic fields instead of clear waves. So we find it really hard if this happened and we needed to communicate to actually tell people that's happened. It would actually be kind of a blackout. So normal devices like your phones and stuff would last probably until the battery runs out, and then you won't be able to charge them. You won't have Wi-Fi. So it probably is the end of the world.
You
can't Snapchat, it's over.
Yeah, exactly. I mean,
so is that going to happen? Like, what's the likelihood?
It happens a good bit. So there was a big one back in 1859. 1859? Yeah, it's 1859.
Yeah, but they didn't have Wi-Fi then.
Yeah, so telegrams failed, which is like a really bad text-based internet for the transition.
The wires burned, didn't they?
Yeah, and people then found they could, even when the power was off, they could send telegrams because there was still power in them. All this weird stuff was happening. Compasses stopped working, which you might imagine the compasses line up with the magnetic field of the Earth, and then that's all messed up. So what happened back then, it was a big solar storm. There was one in 2012 that just missed Earth by I don't know, fractions, big areas in space. But if we get hit by a big one, it's going to affect us more now than it would have in the past because we're more reliant on
electrical stuff.
Yeah, and GPS, and ships go by GPS, and some trains.
Can we do anything about it?
Little bits. It's not as easy as gravity tractors.
I wouldn't say they're easy.
God bless the gravity tractor.
We love our tractors.
So it's mainly shielding. We need to make our
spray paint again. We just paint
paint everything.
Urban art. Back to the urban art.
So our power, basically
go in the sun and
put up a giant shield, block out the sun. So our power systems, they're basically very close to maximum capacity all the time. So when you have this extra bit, that tends to blow it. So if we could have a more robust power network, then when extra power came into, we'd probably be able to deal with any more shielding of cables. So like a USB cable, it's not just bare copper wires. You have this plastic shielding and maybe a metal shielding around it, and that's to stop basically magnetic fields interacting and messing up your USB. So we could shield our satellites better. We could shield our power systems better. But if it's coming at us, it's going to come at us. The best thing, again, maybe we can do is predict when it's going to happen. And I mean, there's research here in Trinity that looks at that. Hey. But basically, they don't know when these things are going to happen. But you can study the sun, and if we knew it was going to come, and a few days' notice, we could turn off the lights and
pray.
And be in prayer.
The sun, our sun has a cycle of kind of 12 years, doesn't it?
Yeah.
So then it goes to solar max and solar min. And
So it's like you can imagine. So it's up and down, and you get a lot less of these solar flares and the coronal mass ejections when it's minimum.
When it's min,
and then you get a lot more when it's max.
So I guess if we're facing, if there's a coronal mass ejection, is it like on one side of the sun? So we could just be unfortunate that one day it could happen on the other side. That poor old Mars gets it or Jupiter, but our orbit is safe.
Yeah, so it's obviously the sun is a sphere, so it can be
in any direction.
In 3 dimensions. Yeah, so most of the time it's just going to get ejected in a place that doesn't bother Earth.
Yeah, so we don't care.
Yeah, but if we get direct hit,
it.
Yeah, well, again, I mean,
scary.
We'd lose all that modern electronics, stuff like that, but I mean, it wouldn't be
any health implications. Long term?
Yeah, I mean, if you're long term, so like the asthma, you can get increased risk of cancer. And so you have ionizing particles that go into your body. And basically do what cancer does, breaks down your cells. And so that, I think, for a normal person, you could, in a plane, you could experience some of those effects, but they'd be very short term and temporary. So you might an itchy skin or something like that. But most of that, those health change, unless it was massive amount of continuous particles coming.
This astronaut, Jeff Hoffman, gave a lecture there last summer I was at, and somebody asked him about, like, did he ever experience any sort of radiation when he was up on the International Space Station? And one night there was a solar storm, and he described it really well. So he was like in his bed, and he said he was asleep, but then it was like there was fireworks going on in his head. So obviously the gamma rays were pinging through his brain and out the other side, so he could see these flashes of light in his brain. So he gets checked, astronauts get checked every 6 months. They get a health check to see if there's any kind of precancerous cells in their body, because they are really exposed to that kind of solar radiation the whole time. Because
it's quite a new thing. We haven't been sending astronauts into space for that long, so the long-term health implications aren't clear. Yeah. But speaking about long-term health implications for our planet, I mean, that's a solar threat we have to worry about. Getting hit by a rock or an asteroid in space, that's likely. I mean, that will happen eventually.
It happens.
It does happen. And the end of everything when the sun explodes is a definite as well. So
it's a given.
Maybe we should talk a little bit about what our options are about going elsewhere. So before we go to Niamh and talk a little bit about how you're going to help us all leave, Mary, your research looks at a planet like Mars and compares it to Earth. Are we comparable enough that we could go live there someday, do you think?
We used to be. Mars used to be very like Earth. Used to have oceans, used to have rivers flowing with H2O, with water. But because of the loss of the magnetic field on Mars, it lost its atmosphere. So now it's no longer protected from the solar storms. It's very, very cold. There isn't an atmosphere that we can breathe readily. And there's loads of hazards like incoming impacts, dust storms, radiation. So there's a huge effort going on to consider the technologies that are required to get humans to Mars, to get them to Mars safely, and then to get them down on Mars, perhaps bring them back, but when they're there, where would they live? So that's definitely something that NASA is investing quite a considerable amount of funding to do. We're not ready at all, but they're thinking 2030. They're thinking 2030 we might send the first humans.
And so by then you'll have a good experience of what it's like in Utah. Is Utah a precursor for what Mars could be like?
Yeah, so Utah is this habitat that's been established by a society called the Mars Society. So since the late 1990s, a man called Robert Zubrin set up this society because he wanted to genuinely contribute to the effort of getting humans to Mars. So it's a society that works outside of the space agencies, and it's a great facility because it provides people working in academia and in government research to go and test out different elements of science of what they're working on and bring it back. So they've got about 500 publications, legitimate publications from scientists out there. The reason why they pick Utah is it's a pretty extreme environment. It's in the middle of nowhere. So the closest I can fly into is a place called Grand Junction, and then it's a 2.5-hour drive to the hab, as they call it, or the habitat, and we're just left there for 2 weeks. And the environment looks really Mars-like, seemingly. I spoke to Mark O'Griefa last night. He's the flight surgeon for the habitat, and he was out there. He had to look at it before he took on that job, and he was saying, like, you look around, it really feels like Mars. Now, it's not Mars, because obviously we have an atmosphere, and we are still actually on Earth with a gravitational force of 9.81 metres per second squared and all that, but it allows people kind of simulate circumstances as best we can. So what are the things that we can look at? We can look at how communities form. So it's very important psychologically for crew to be properly assessed and to have the right kind of mix of team. That's something I'm going to be looking at closely when I'm there. I'm there as an artist, and I'm also really interested in human behaviour in that regard.
Will you be leaving? Are you stuck inside?
We're stuck inside. We schedule our EVAs, which is the fancy word for basically going outside in this term, but they're extravehicular activities. But we have to garb up, we have to wear the kit and everything when we go out. We have there's an observatory there as well, which I'd love to have a go at as well, because I'd say the night sky there is amazing. But what was your question?
How long are you there for?
Oh, yes, sorry, I'm there. Sorry, for 2 weeks. So I'm just there for 2 weeks, and they only ever have you there for 2 weeks because they only open it for 8 months, kind of in the winter-spring phase, because the summer there, you'd bake alive, literally, in the desert, obviously. And so we've got a couple of things. So the lads that I'm working with, they're from Israel, France, Spain, Australia, Ireland and Slovakia, and they've all contributed different experiments to it. I'm kind of floating. I'm the journal person. I'm keeping track of what's happening on a daily basis, and I'm there as the artist in residence to document the whole thing. But I am jumping in and helping wherever I can. So there's kind of three things. There's a geologist who's actually taking samples. He wants to gather as many samples as he can. He's using an on-site spectrophotometer to see if he can find carbonate materials and minerals, because again, it's really to kind of test the equipment back in his institute in Israel, because once they get samples from Mars, they want to know how many carbonate materials are there, because it will give a good key to the likelihood of where water is, and also if there's any inorganic carbon on the planet of Mars. So that's what he's doing. We have a couple of engineers and scientists who are figuring out a kind of a modular system of a brick, a 3D printed brick. So we'll be bringing 3D printers in, 3D printers. It takes 12 hours to print one brick. So we're trying to print 40 bricks when we're there, and we're going to bring in some. We'll go out in an EVA, and we're going to fill some of it. So it's a brick which kind of like two parts to it. One is like an inlet for water, and another part is for regolith, which is the fancy word for soil, basically. And the reason for that is that water is a great insulator against radiation. So we're going to try and build a wall. And we're going to try different...
Build a wall.
Build a wall. Oh, yeah. Build a wall. And we're going to try and build a wall using kind of... They've got a kind of a honeycomb one, kind of a brick that looks like a kind of a domestic brick, except it kind of interlocks, like tongue and groove of laminate flooring would be something that would be akin to it. And then there's another shape. I can't remember. It's kind of like a tetrahedron-y kind of shape. So they've got three ones on the go. The printer's going to be working all day and night. We're bringing in, another engineer has created a generator, a solar power generator, because we need an extra 600 watts of power to do that. So that's that one. And then we have two astrobiologists that are trying to figure out the amount of cadmium that plants uptake in hydroponic solutions, because when we go to Mars, we can't rely on soil to grow our plants, and we need plants. And also when we're travelling there for 7 months, or maybe 100 days, if Elon Musk from SpaceX is right, to eat when we get there. So we're going to be relying on solutions of nutrients to feed plants instead of soil. And one of the big killers of plants is uptake of heavy metals, cadmium being one of them. So Michaela and her team and Rick from Australia have designed an experiment called Mars Electro, where they have this sort of electrochemical sensor to figure out the amount of uptake of plants. If they plant cadmium in a solution of nutrients, how much does a plant uptake? And then we're doing this really easy one where we're just going to be carrying around space food to see how long does it go off. There's going to be bacteria in it. So we'll be carrying them on EVAs, we'll have them in the hab, and then we'll have them outside, and that'll be kind of just bacteriological sensing.
Oh, will you have contact with the outside world? Like if we wanted to be kept up to date on your...
No, we have really limited broadband, really limited. We only have enough to kind of give our daily report, and very, very limited after that. And if we need to communicate, we have to restrict ourselves to the 20-minute delay, because that's a realistic delay between Earth and Mars. If something goes wrong, we can call a kind of our emergency phone, which would be Mark, in the event of something going wrong. But no, we have to stick to, we are on Mars for the whole time. So comms is limited, and it's just like really simple broadband where you just kind of say, this is our log of the day, and we have someone out on off-site in America. And the other part of our experiment is basically what happens if things go wrong. So we have a series of simulated accidents that can happen, and how we communicate those with that 20-minute delay and what we do. So that's another experiment that we're doing.
Okay, we're going to open up for questions in a minute or two, so don't forget that if you want to tweet us, you can as well. We're happy for you to tweet questions, and also nice comments about David, and yeah, lots of nice things here. Nice.
Just David, thanks guys.
Yeah. Give the people what they want. People are just here to see David. It's fine. Not bitter at all. Okay, before we move on to the questions, given that we've heard some pretty scary threats, what would be the worst way to go? In terms of cosmic threats, which would be the worst one for Earth?
I think the asteroid hitting but not killing us immediately.
Yeah.
I heard the one about that pushing up dust into the atmosphere and blocking out the sun, and then us just kind
of... It's road.
That road, is it?
It's road.
That sounds like a good movie. Yeah, so that sounds like the worst way to go in terms of then you just will die without sun.
Slowly.
So let's not do that.
Okay.
road. I really don't want to go that way, where we end up eating each other and kind of harvesting people for food. It's like, oh God, no.
I read the book thinking there was going to be
Oh
like
my
a happy
God.
ending.
It's just so terrifying. That's terrifying. And I Am Legend is pretty scary too, where people turn into zombies. If something happens for people to turn into zombies, I fear that too.
But yeah. we can have enough to worry about with things coming from outer space then worrying about zombies as well.
Yeah.
Don't make me worry about zombies
I
as
know,
well.
but you see, maybe if people get radiated or something, I don't know. I'm scared.
Mary, what do you fear most?
Well,
my questions.
in terms of, I actually think there's so. Do you want it to be a spaceborne one?
Well, it can be. I mean, I'm aware that
We have so many natural hazards here that we're trying to deal with, and we're still not have the full technological capabilities. Okay, well, look at earthquakes that affect Japan versus Haiti. Okay, the impact of those is astronomical in a society like Haiti that doesn't have the infrastructure to prepare for a lower magnitude earthquake versus Japan that has all these engineers that have designed buildings that can wave and go with the flow. I mean, we have so many issues here on Earth that I am actually more terrified for certain societies on our planet about known hazards here that are geological. Yeah.
Something else to worry about.
And running out of water as well. Like we might run out of water. If our population gets really big, we could have a food problem, food scarcity and water issue as well. There's lots of things that we should be worrying about.
But science will save the day. I mean, this is where we have to invest in science. Seriously, like our engineers and our scientists are going to come up with solutions to many of these issues if the politics would get out of the way.
Yeah.
And if only we had a pool of young people who like science and would somehow save the day for us.
From Blessington,
if only there were some
I hear
TY
Blessington
students.
has a great cohort of very smart and enthusiastic young ones.
Armageddon 2, Blessington saves the day.
From somewhere like Blessington, I don't know.
Are there other schools here other than Blessington, or are we just... No, then we can keep just praising Blessington.
Just Blessington specific.
Yes.
Okay, we're going to start taking some questions. We have one up the back, do we? Oh no, so you were saying you're from a school other than Blessington. Does anyone have a question for our panel on the end of everything? It can be about any specific threat. Yes?
Yeah, you said that you referred to Mars having lost its magnetic field.
Yeah.
Sorry. Mars having lost its magnetic field. I haven't a clue about it. I've been in business all my life. How did that happen? And did it happen here?
Yes. Basically, there's a couple of ideas around. The most popular one is that the core of the planet cooled down. It just solidified. So the magnetic field is created by dynamism that the core moves and the molten stuff around it also moves in differential speeds, and that creates your magnetic field. And it's like this force field that protects us from incoming radiation, etc. And so once Mars is such a smaller planet that it cooled down faster than Earth. But yes, the idea that some people have is that is the ultimate. If the sun doesn't get us, that'll happen for our planet. Yeah.
Can I ask Mary a question? Actually,
Of course,
I want to say to you. Mary, I was at the talk that Elon Musk gave about the big grand designs, like for SpaceX to have this sort of spacecraft to bring 100 people to Mars and everything. And it was really good in an engineering point of view, but then the science kind of broke down when he suddenly made Mars spin and we had water. So, so terraforming.
There's loads of water on Mars. There's two polar caps.
So, like, what's involved in terraforming? Like, what would you have to do for that
Change
to
the
happen?
atmosphere.
So how did they do that?
Well, basically, if you put in, you can change the density. The atmosphere on Mars changes its density seasonally anyway, because you have CO2 rich atmosphere, and it gets so cold that all of that CO2 gas condenses on the surface as snow and as ice, these huge meter-thick slabs of ice. So the density of the atmosphere changes. So if you were to put something into the atmosphere, like carbon dioxide, like dust from causing explosions that we've described in terms of the impact crater, you could change that. And then there is water on Mars. You would increase the temperature. So we have these global dust storms, and we know that the temperature both initially increases then decreases at those times during those years. So you have ice near the poles at the surface, and as you go towards the equator, it kind of goes deeper and deeper and deeper. But if you were able to access that through these processes, you could put that into the atmosphere, and then you would have increased water vapor in the atmosphere.
And how long? What time length would that take?
I don't know, but it's in the order of hundreds to thousands of years. It's not something
not
like
tomorrow,
that.
Then.
It's not for his 100 people. No.
No, not by 2030 then.
No, not in terms of creating a whole suite of other. With a new atmosphere comes winds. Can humans stand in the winds on Mars? And the structures will they be designed for that?
Yeah, great. Thanks.
We have a couple of comments from the audience. Maybe we should have talked more about astrobiologists saving us, but none of us are astrobiologists.
No, but
so
I mentioned it.
You did mention it?
I have
Yep.
2 astrobiologists on my mission.
They'll save
They're
us.
amazing. They'll save us. They're amazing. Any
well-
astrobiologists here? That's a no.
Okay, not yet.
Not yet, T-wise.
I feel like we're putting a lot of pressure on you guys. Sorry.
No pressure.
Please come back.
job.
You're very welcome here. Do we have another question? Yep, we've one over here.
You said anything about the rogue black holes?
Rogue black holes. Yeah, that was something that came up and we discussed before, and we thought, like, it's going to be a lot of depressing things. Maybe we shouldn't bring up black holes. But here they are, black holes. Let's go.
You're an astrophysicist.
I'll take this one.
Yeah, go on, Joe. Give us a juicy something. Come on.
Well, gather round, I shall tell you a tale. Black holes are something that we are worried about and we are concerned about. But in the scale of threats we have, they come in the area where we don't know enough about the science behind them to even begin to imagine how worried we should be. So it's kind of one of those things where we know it's out there, and yep, that could probably kill us as well. But if we choose to ignore it for long enough, maybe it won't be an issue. But it's kind of like Trump with climate change. You just, like, if you pretend that the problem isn't there, it's still there. It's getting worse. But black holes, we don't understand the physics behind black holes well enough yet. A similar point could be made about gamma ray bursts. Gamma ray bursts are something we do understand much better, and they are something we should be worried about. But probably we'll all be dead because of climate change before that. So maybe it's not something we have to worry about straight away. Does anyone else want to comment on black holes? Or
So what's a rogue black hole? Like, it could just pop up one day or something?
well, see, the thing with black holes is like dark energy or dark matter. Anything with black or dark in the name is usually, in terms of astrophysics, we can't see it, we don't understand it, we don't know where it is. Black holes, we can only detect them. They obviously they don't emit light. Nothing can escape from them. Not even light can escape from them. So they're very hard for us to see and detect. So they can sometimes start to form without us realizing, and sometimes they can, if they reach a critical point where they start absorbing matter around them and growing, then that's a cause for concern. Now we probably would be able to detect them from their influence on the matter around them. So if we see stars in the sky moving faster than they should, all towards one location in the sky, then it's
And would
rogue
it happen
black
really
hole.
fast, or are we talking hundreds of thousands of years again?
Yeah, no, I mean, most of these threats, they happen very, very slowly at the start. But then right at the end, you get killed really quickly. So you don't have to suffer. Yes?
Okay, the inevitable return of the Ice Age in the next 50,000 years.
Yeah, less of a space-based threat, but does have an impact.
Well, it's controlled by
some-
space dynamics
Yep.
in many ways. Yeah, climate change is a very natural process. Yeah, and so whether we'll have the technology. So what happened in the last space age, that's very well documented in terms of changes in vegetation, changes in the climate in terms of wind speed, rainfall, all of that kind of thing. But you do have these physical manifestations that grow over our landscape and consume our landscape. And so the northern hemisphere and higher topographic areas would be most prone to that kind of physical hazard, and where all structures would be destroyed unless technology decided that we didn't want to allow them to grow, and we harvested the water because they're formed by just snowfall and rainfall. And if you can somehow change that balance of going into the structure and move it elsewhere, which we probably would have to do. Yeah, but that's definitely an inevitable. Yeah.
Any other questions? Yep, we have a student down the back.
I have a question about the gravity tractors. How exactly would they work, and how big must they be to work?
So in terms of size, they don't have to be that big. It really depends on how big the asteroid is that you want to move, right? So to get the same kind of movement from a big asteroid, you need a big gravity tractor. So in general, it'd be that your asteroid's going along, and then you'd pull your spacecraft up kind of beside it and try to keep it there. So if you're orbiting, then the kind of pull kind of would balance out. It wouldn't really go anywhere. So you can try to keep it on the side. Now, if you have any two objects with mass, Newton's law of gravitation says that they're attracted to each other. Okay, that's proportional to their mass, right? So the bigger the mass of your tractor is, the bigger the push, the traction between them, and it's the closer you are, the closer you're squared, then that force gets bigger as well. So you want to be close to it, not that you're dangerous, that you're going to hit the asteroid, or if there's gases coming off it. It's going to wreck your tractor, right? So again, you kind of think, when you think about moving asteroids, that it's like you have to go, whoa, we got to go take a right-hand turn. Again, it's going to be over a number of years. It's just going to edge very, very slightly over. So again, it goes to think we need to be able to detect them as early as possible.
So I saw something about it takes about 10 years
Yeah.
to allow a manoeuvre of about a centimetre, and that should be enough.
Well, that's going to do. Yeah, if you start it early enough, it's.
Has anyone made a tractor yet?
No.
Can I have a go on one? A Massey.
So there's a NEO-SHIELD. European Space Agency have a NEO-SHIELD program that they look at. Well, I mean, it's Europe. I'm not sure it's European Space Agency, but it's a lot of countries coming together, and they're looking at designs for all these things. The kinetic impactor, the one that you bash into it. Actually, I mentioned one of the ideas of bashing into it is that you bash into it and you kind of heat up the surface, and then that creates a gas, and then that pushes it like kind of a rocket motor.
And we did that. There was Comet Temple 1, and we sent, what was it called? Impact, what was it? There was a spacecraft we sent out to observe this comet go around, take all of its images, and its last mission was to slam into the surface because it wanted to create an explosion to see what was inside this comet, which is generally a very porous, fractured surface with snow, with ice. And so it sent out all of this snow and ice into space, and they were able to image it with their sensors. But that was the first real trial of basically, well, what happens if we do smash something in? What happens then to the trajectory of the comet and its voyage around the sun? So we do have some.
I think, a mission like Rosetta that observes a comet and tells us more about it does make us feel a little bit more, or maybe a little bit less worried about threats because our technology is catching up. I'm conscious that we've probably given people a lot to worry about.
Yeah.
So could I ask you quickly, the three of you, if you had to think of like what is the thing that gives you hope for the future of Earth? It doesn't have to be a space-based thing, but you're going to say Blessington again.
Yeah, I love Blessington.
There are other schools, surely.
What school are you from? New Ross Vocational.
Oh, you've got two schools.
Any other schools?
Any other schools?
And, so I think it's something else then. Well, maybe back to what Mary was talking about, that I think whatever really happens, even if one of these massive coronal mass ejections, it probably won't affect whole Earth, and there probably will be a pocket of people alive after most of these things, unless it's a massive asteroid. And I think, the kind of human spirit, I think we'll survive. That's the human condition, to keep going. So I think that gives you hope.
Okay.
What was the question again?
I don't remember.
What did you hope?
What would I hope for?
What would you hope for, yes.
What would I hope for? My God, what would I hope for? I think, like what Dave says, I think humans are incredibly resilient. I think it's in our DNA to explore and to figure out what lies beyond, and I think that need to understand is the driving force behind all curiosity and science. And I think as long as we encourage that and kind of nurture that, I think we will find a way. If our species is wiped out, then we are still part of star stuff, There is a cycle of life. Maybe our time is up, like the mammoth. And as you say, maybe it's the time for the cockroach or something else. Or
That's the cockroach.
You know what I mean?
Finally.
So, I think in some way we have to be philosophical. Like, if our time's up, our time's up. And let's live the life we want to live now to the best of our ability and live every day as if it's your last. I feel like I should burst into song. But yeah,
and
you know what I
might.
mean? Like, let's embrace that. Let's just go, that's okay then. That's us done. You know what I mean? But we're now going to, our atoms and our electrons and our protons are going to become something even more beautiful. So here we go.
To hear more cheery messages from Niamh, as part of Science Week, you'll be doing a couple of shows.
Yes, I'm like a little robot this week, Joe, of stuff.
Where can we see you?
For my, I want to tell everybody my story of why I want to go to space, because it really is about bringing people with me on that journey. And so I made a theatre show in 2014, which was supported by Science Gallery here, about what happened in 2014 and my need to go to space. And that's going to be on in Smock Alley on Thursday night at 8 o'clock. And it's the last time I'll ever be performing it, because I'm very happy to say that I kind of think the show's out of date. And then tomorrow night, I want to kind of take people on the whole thing from start to finish and kind of explain in more detail about why this happened and where I'm at now and where I'm going in the future. So it's kind of it's a broader lecture, and it will bring in elements of what's happening in ESA, what's happening in people going to Mars. And that's tomorrow night in the Arc at 6 p.m. It's a free event, and you can book tickets online.
And if you manage to make it through the next couple of days of Science Week, you can go to Science Hack Day.
Science Hack Day. So I'm running Science Hack Day on Saturday and Sunday, which is a hackathon where people come on a Saturday and have nothing and then work all through the day and all through the night if they want, and end up with something, building something or solving a problem. We can build a gravity tractor or something like that.
Gravity tractor.
Yeah, so details at sciencehackday.com, sciencehackdaydublin.com. It's for over 18s only, so the per lesson kids. I'm sorry, guys.
You can get in, don't worry. You know David now, just say David, it'll be fine. Remember, science is not just for Science Week. Science Gallery is open all year round. This is part of the End is Nigh series, of which there are 2 more events. Tomorrow night, 6 to 8, there's an event in the End is Nigh series looking at AI and how that's going to kill everyone. And then
it's lovely, isn't it? It's such a lovely week.
Whose idea was it?
So lovely.
The following night at 6 o'clock here again, we have the End is Nigh focusing on climate change and how that will kill everyone. Please do consider science as something you might pursue in school. Come to college, come to Trinity. Myself, Mary, David, Niamh, we're all happy to talk to you about your careers, your options. You can catch us on our Twitter handles, on our hashtags. I guess it just leaves me to thank my panel.
Yeah.
Are we doing a selfie?
We're going to do a selfie, I promised Mr. Teacher from Blessington.
We'll do a selfie. Okay, so before we run away, give Niamh a chance to do her selfie.
Yeah.
But just maybe you can join me in thanking our panelists for coming in and for being here for this event.